This is Miss Hughes, and today we are looking at identifying cubic and exponential patterns and finding their equations. Now, just a quick recap first of what we did with quadratic sequences. Here is a quadratic sequence, and let's just remind ourselves of what we did to identify that it was a quadratic sequence and to find its equation. So we started by looking at the first differences. So we did this term minus this one and extended all the way down. The differences were not constant, so we realized it wasn't just a linear, so we tried the second differences. So equals this cell minus this one. And we found that the differences were constant this time. Now, if you remember, what that meant was that the sequence was quadratic because we had to go to the second differences, and we also had to halve the second differences to get the coefficient of n squared. So in this case, this particular sequence involves 6n squared. Okay, and then we did a few other things to find out what else was in the sequence. But let's now have a look at two other types of sequences, which are cubic and exponential. Now, we realize here that finding the differences is very, very helpful. So what I've done on this sheet is I've just listed basic cubic sequences: n cubed, 2n cubed, 3n cubed, and 4n cubed. Now take a minute just to understand how I've got this column and what that involves. So here, for example, I've asked the spreadsheet to give me 4 times this number cubed. Okay, so press pause if you need to for a moment, just make sure you understand how that column was calculated. Okay, and I then did my first differences. I then did my second differences, and that wasn't enough, so I went all the way to my third differences. Just a point here, there's a summary at the end of all of this, so if you just want to watch for now and then summarize at the end, that's okay. Alright, so the third differences were constant when the formulas were cubic, and there's also a link. So when the formula was n cubed, the third differences were 6. When the formula was 2n cubed, third differences were 12. 3n cubed, the third differences were 18. 4n cubed, the third differences were 24. So hopefully you've noticed that to get the coefficient of n cubed, we need to divide the third differences by 6. Let's just put it to the test. So if I try n 1, 2, 3, 4, 5, and I try 5n cubed, so 5 times this number cubed, and extend it all the way down and find my differences. I'm expecting the third differences to be 6 times 5, so 30. Let's see if that happens. Equals this times this, so this is the second differences, still not constant. So let's try the third differences, equals this minus this, and they do settle down at 30. Okay, so what we've picked up from this, the key thing is that if the third differences are constant, then the formula is cubic, and to find the coefficient of n cubed, I need to divide this third difference by 6. Okay, whereas in the quadratic, I needed to divide by 2, cubic, I need to divide by 6. All right, so let's put that into practice. So here I've got a pattern. Again, just watch for now. You can always press pause and try it and copy it down later, and you'll get a chance to practice at the end. I'm going to find my first differences equals this minus this, and all the way down. They're not constant, so I know that it's not just a linear pattern. Let's see if it's a quadratic. This minus this. Still not constant, so it's definitely not a quadratic. Let's try the third difference. So equals this minus this. And the third differences are constant. Now if you remember, this is 6 times the coefficient of n cubed. So that means the coefficient of n cubed is 42 divided by 7. No, sorry, divided by 6, which is 7. So what that tells me is that the formula, the pattern, involves 7n cubed. Okay, take a minute just to make sure you've understood that. Okay, so what I'm going to do is I'm going to copy this table because that's our aim. Our aim is to find a formula for this particular table. And I'm going to get the spreadsheet to give me 7n cubed because I know that part of the formula is 7n cubed. So equals 7 times n cubed. Okay. Now, our aim, if you remember, is to find the formula for this particular column. And the kind of examples that we are going to do throughout this unit are going to be fairly simple. So once you've figured out that it's 7n cubed, we're going to find the formula for this just by inspection. So just by looking at the numbers and seeing if we can find a link. Now take a minute to look at those numbers. This is the 7n cubed. Can you see the link between these numbers and the numbers here? Now hopefully you notice that these numbers are just 3 more than these numbers. So the formula for this particular pattern is 7m equals 7n cubed plus 3. And we're going to put it to the test. So 1, 2, 3, 4, 5. I'm going to list equals 7 times this number cubed. And then I think the formula is also plus 3. I think that's what my formula is. If I've done it right, I should get these numbers. Let's see. And bingo, it's worked. I know I've got the right formula. Okay, so we just decided that it was 7n cubed and then we compared to see what the formula for this was. Let's try that again on the next one. Okay, so first differences. And second differences. And third differences. Super. Okay, so first, second diff, and third diff. It's really important that you keep track of your columns because when you do your write-up, it's going to be a lot easier if you know what you've been doing. Okay, so the third differences are constant, which means the formula is cubic, and it will involve, the coefficient will be 30 divided by 6. So 30 divided by 6 equals 5. So that means the formula involves 5n cubed. I'm going to copy this table because that's the one I'm interested in. I'm going to list 5n cubed. Well, I'm going to get the spreadsheet to do it for me. So equals 5 times this number cubed. And again, I'm just going to compare these. And hopefully you can see that these numbers are 4 less than these numbers. So the formula for this is m equals 5n cubed minus 4. And if you're not sure, like as we've done before, put it to the test. So equals 5 times this number cubed minus 4, and we get exactly the right answers. Okay, so that's cubic. Now there are times in the examples that you're going to do in a moment. In fact, let's go ahead and do this straight away. This is the next example. I'm going to find my first difference equals that minus that. And I'm going to find my second difference. to find my third difference. And they are not constant, okay? And you can see that probably that there's a little bit of a pattern and it's never going to be, so it's not just that it's to the power of 4. So I've got to think a little bit about other functions that I know. So we've done linear, we've done quadratic, we've done cubic. One we haven't done is powers. So different powers. Now, if you think about it, the numbers here are doubling. And you should recognize these numbers as the powers of 2. So this particular pattern might involve the powers of 2. Now, before we carry on with this pattern, let's just go back a little bit. Here I've listed, because we think, okay, so maybe if it's not a quadratic, it's not a cubic, it might involve powers. So what I've done here is I've listed the powers of 2, the powers of 3, the powers of 4, the powers of 5. Press pause for a moment and check that you understand this column. Okay, now in each of these cases, I went all the way to the third differences and wasn't getting a constant. But if you look at what's happening with these numbers, it's something pretty telling. So these numbers are all being doubled. These numbers are all being tripled. These numbers are all being quadrupled. And these numbers are all being multiplied by 5. So when it's a power, when it's something involving 2 to the n or 3 to the n or 5 to the n, the thing that's the first differences, and we don't even need to do the second and third differences, is they're being multiplied by the base. So here they're being doubled, tripled, quadrupled, multiplied by 5. All right, so let's go back to the one that we just had. We said the second, third difference didn't help because it wasn't quadratic or cubic. But the numbers are being doubled. So that tells me that the formula, so the first difference is double, which means the pattern involves 2 to the n. And again, just as before, we're going to copy the table. We're going to list 2 to the n. So 2 to the n is 2 to the power 1. Now, I'm just going to do that step again. So I'm doing equals 2 to the power 1. Okay, and that time it works. There are some times when the spreadsheet for some reason changes this to a plus. I'll show you with the next one. So if you do 2 to the power this, it somehow changes it to a plus. So just be very, very careful. If you find out why and can tell me, please do. But if it does that, just go back and check that it changes into a power, that you keep it as a power. All right, so these are the powers of 2. And again, we're just going to compare. Well, this is the formula for this is 2 to the n. These numbers are 3 more than these numbers. So the formula for the m column is it's 2 to the n plus 3. And just to be sure, I'm going to put it to the test. I'm going to list this formula, so let's put it down here. Equals 2 to the power of n. Again, it's changed it to a plus, and I don't know why. So to the power plus 3. Oops. Let's go back. Try again. 2 to the power of this plus 3. Press enter and extend, and I can be 100% sure that I have the right formula. Okay, last example. Let's look at the differences. So equals this minus this. Okay, now if you look at it, the numbers are being tripled here. So the formula will involve 3 to the power n. So let's copy that down here. And I'm going to list 3 to the power n equals 3 to the power of 1. Make sure that's up power 1. Extend it all the way. Right, and just by looking at this, we can tell that these numbers are 10 times these numbers. So the formula is m equals 10 times 3 to the power n. Now you may be a little bit tempted to do 10 times 3 is 30, but be very careful. PEMDAS order of operation says this power only applies to the 3. Let's put it to the test. 1, 2, 3, 4, 5 equals 10 times 3 to the power 1. Change that to a power. And I know I'm exactly right. Okay. So on the next sheet is a summary. In summary, if the first differences are constants, then the pattern is linear, and the first difference gives you a coefficient of n. If the second differences are constant, then the pattern is quadratic. You divide the second difference by 2 to get the coefficient of n squared. If the third differences are constant, then the pattern is cubic, and you divide the second difference by 6 to get the coefficient of n cubed. If the values in the first difference column are being doubled, then the pattern is exponential and based on 2 to the power n. Now I'm just going to pause for a moment because I realise that actually if we go back to here, we don't actually even need to look at the first difference if the numbers themselves are being doubled or tripled or quadrupled. I think that works all the way through. Does it work all the way through? No, I lie. It's got to be the first difference. Okay, so this is correct. If the first difference in the column are being tripled, then it's based on 3 to the n. If they're being multiplied by 4, then it's exponential and based on 4 to the n. So, just 2 questions for you to try. Press pause, and when you're ready to see the answers, press play. And here are the solutions. I'm going to get rid of this box, and I'm just going to work through the solutions. I'm not going to talk, see if you get the right answer.